Yeah, I'm doing a lightning talk, so this will be quick, and it's only a little functional programming because Rust really isn't a functional programming language, so don't expect too much. Don't want to get your hopes up. So what's Rust? Rust is a new programming language. 1.0 came out a year ago. It's from Mozilla, so they wrote it to basically write an efficient web browser that's safe and has no buffer overflows and can do multi-threading without interfering with itself. Yeah, that project is called Servo, if you want to check it out. It's a system programming language, so you can, it's close to the metal, you can control every detail of what your program does. Yeah, memory safety is guaranteed statically. Very nice stuff. Zero cost abstractions. You write something that looks very high level, but it compiles down to something that is very low level. So no runtime overhead is involved. That's some ideas of the Rust language. It also has a quite strong type system and pattern matching. So it's I thought maybe I'd show you some of the functional programming capabilities of the thing. So what can it do? It has an extended library, convenience functions for functional programmers like fold, map, take, filter, and stuff like that. Types and matching, you can just write closures and it works. You can return functions. You can have functions as arguments. It doesn't support object-oriented programming, so yeah, you have to program somehow, so why not functional? And it has some type inference, you don't have to always type the type. It doesn't have tail call optimization, which means if you have a tail recursive function, you still will build up a stack. This might be fixed in future with an opt-in thing. You can't have the mathematical kind of functions with no side effects. And do you know currying? Anybody does not know currying? Okay, so if you have a function with multiple parameters, then it's good functional style to, like, you give the function one parameter and then you get out a function that takes one less parameters. And in real functional languages, there's cool syntax for it, but there's not here. So if you want to do this here, you really have to have a function that takes one parameter and explicitly return a closure that takes then the other parameters. So maybe this will come. I don't know. I don't know anything about it. So yeah, let's look at some code. So I said it has some cool types. You have inductive types here. This enum is way more than a C enum. It means basically you have one of these variants, but these variants are not just numbers, but they can have stuff like elem here has an integer. I32 means 32-bit signed integer. And it has a pointer to the next list element, so this is a singly linked list. And one thing is just a struct, it's just a compound. Yeah, you can have the vec is basically an array, dynamic array. This parentheses is tuples, so this is a pair. You can have tuples, which is cool for functional programming. And you can have option types, which is also an enum. So yeah, you have all kinds of stuff. Then this is a more useful list that's actually more usable. It's also a single linked list, but it's more complicated. This RC thing, it does reference counting. Yeah, so the top left is a simple linked list, but to actually use it is quite hard because you have to copy stuff all around to satisfy the Rust compiler, which is really strict. And the one on the right is more useful, but it's kind of above this talk to explain because it's quite a long explanation, but I'll leave it. Just so you see, it's not really only tailored to functional programming. Okay, so let's have a look at some code. This is a function imperatively written that calculates the distance between 2 points in an n-dimensional space. So, like you get 2 vectors, like vectors of length 2 for 2-dimensional, and then you calculate the distance between those points. So you know how it works. For every index, calculate the difference, square it, add it to the result, and at the end return the square root. There's no return here because Rust is expression based, so the last expression is returned. You could put a return here, but it's bad style. You have a question?
The expression 0.x what? If say x
it's an iterator.
Okay, so if x length is 3, what would be the values taken by now?
2. It's like in Python with the range thing,
okay, so
that the value that you write is excluded.
Alright.
Because it's tailored for this case. So you don't want to always write x.len -1 if you want to iterate over x. Okay. So let's functionalify this. So let's use all the stuff we like. We want to iterate over the vectors and fold it together somehow, because we like fold, right? So we iterate over x and we zip it. Do you know zip? It's it takes 2 iterators of elements and gives out 1 iterator of pairs of elements. So yeah, here we have an example of a closure. We get in the accumulator and the new pair, and we can just again calculate the difference, add it, and in the end we square it. So this all is one single expression, which is nice for functional programming. Okay, so I have more stuff and I have links. I don't know if you want to see it. So this is a formula for polar to Cartesian coordinate conversion. I needed to write it recently, and I wrote it like this. Don't know if you want to talk about it. I also have some links here where you can have a look. Of course, obviously, also language documentation and stuff like that. So what I really wanted to say is just you can do functional programming things in Rust, and I like that. And maybe you want to check it out because Rust is a nice language. Yeah, should I explain this, or do you want to ask questions? Or no? What do you do? You are the kings here.
So if we go back to compare it to the presentation of the previous one. Yeah, the previous one. Were you arguing the second one is better?
It's more functionally.
Yes, it's not more readable to me. But,
yeah, it's. I think it's a matter of taste. So when you read something like this, then it's obvious that Rust isn't really built to do functional programming as the main type of programming. Because like in a real functional language, you write zip x, comma, y, and then fold, and so there are so many symbols there that wouldn't have to be there in a functional programming language. Like this dot iter, and yeah. But you can, and it's cool. Yeah.
With some syntax, like the do or the for comprehension.
What do you mean?
The do notation in Haskell, for example, which translates to composition of single steps computations.
So you mean compound functions?
yeah, if you have an I/O, for example.
No, I don't think that there's a syntax for that.
So it's not primarily functional, but it's possible to do some functionality.
That's why it's called a little functional programming.
Therefore, so mutable and immutable variables.
Yeah, actually, if you declare some variable with this let thing, then it's immutable. If you want it to be mutable, you have to write let mut. So it's immutability by default.
Do you know companies around here that do Rust?
No, I don't, but they are very active on Twitter. So there's this week in Rust account. They tell you what's going on this week in Rust, and they also announce when a company is searching for somebody doing Rust. So the market for this is so small that they can put it on a single website, but it is said that there are opportunities, but not. Probably not like here, except if you do one yourself, like found a company that does cool things with Rust.
That's in the works.
Yeah, I mean, if you can say, oh, my company uses Rust because we are doing a very secure product, we are unvulnerable to any buffer overflow attacks, use after free and stuff like that. It's cool.
I don't think that would move a client. It would move a programmer that wants to work for you. That's signaling, social signaling, saying, "Hey, I know what functional programming is. Come work for me."
Functional programming.
Oh, that's not. That's just saying we know that this thing exists. We just don't believe there's only Java and C++. That might interest some people.
If you want to convince a client, then you can always show, like, okay, there are so many found vulnerabilities with buffer overflows each year, and we can't have that by design, so we're more secure.
Exactly, that's why we're going to use Java.
Yeah, but we're also fast. Because Rust is, I forgot to mention, it's compiled with LLVM, and it's compiled down to native code, and yeah, as many checks as possible are done at compile time, so the code is really fast. In some very rare cases, it's even faster than C++ implementation, because Rust is a very verbose language, and the compiler sometimes knows more stuff about the code. So it can optimize things that it in C++ sometimes can't, but it's very rare cases. So, yeah. And there are still many cases where the Rust compiler isn't as optimal yet as a C++ compiler.